So now we'll put all of that together and look at how we graph. And there's 7 steps to graphing. The first thing is we'll look at symmetry, and we'll talk about that more as we do the problem. But for even symmetry, we replace x with negative x and compare to the original. For odd symmetry, we replace x with negative x and multiply original by -1. Those are 2 separate steps, and then we compare those two. Okay, if those two are the same, then there's odd. If replacing x with negative x, if that's the same as the original, then it's even. Then we'll find a y-intercept, and we've done this several times now. To find y-intercepts, we always make x equal 0. And then we'll find an x-intercept. Again, always makes y 0 for the x-intercept. And then we found the vertical asymptotes a little bit ago. Remember, that means that we set the denominator equal to 0. We might figure out what x's cannot work in that problem. And then we'll find the horizontal asymptote. Remember, that has to do with the degree. We just did that at the end of the last video. And then we'll plot any points we need, and we'll draw our graph. So let's see how this works in practice. So step 1 says that we're going to look at symmetry. So we're going to start by replacing x with negative x. So I'm going to have 3 times negative x minus 3 and negative x minus 2. If I simplify that, I get negative 3x minus 3 over negative x minus 2. And if I compare this to the original problem, it's not the same. So it's not even. Then I want to go back to the original if it's not even. If it's even, I can stop. If this right here is the same as the original, then I know it's even and I can quit. But if it's not, then I'm going to go back to the original, and I'm going to multiply the original by -1. And we can put a 1 on the bottom just to see that I'm multiplying that -1 into the top part of my equation. And then I need to compare this with a -1 to where I replaced x with negative x. And they're not the same either. So it's not odd. So what we found here is step 1 tells us there's no symmetry in this problem. So step 2 then says we're going to look for the y-intercept. And we do this by making x be 0. So I get y is equal to 3 times 0 minus 3 over 0 minus 2. This is 0 minus 3 over 0 minus 2, which is -3 over -2. And that simplifies to 3 over 2. So my my y-intercept, is x equals 0, y equals 3 over 2. Negative divided by a negative is a positive. So let's go ahead and put that on the graph. I'm going to put it on in purple. So it's a point on the y-axis at 3 over 2, which is 3/2. Step 3 says I need to find the x-intercept. That means we make y equal 0. So I have 0 is equal to 3x minus 3 over x minus 2. And multiply both sides by this denominator to get rid of it so that I don't have a fraction. So on the right side it cancels out. On the left side we have x minus 2 times 0, and x minus 2 times 0 is just 0. Add 3 to both sides, and divide by 3, and get x equals 1. So x is 1, and I made y be 0, which gives me a point on the x-axis at 1. So step 3 was the x-intercept at 1, 0, and I graphed that in blue. Step 4 is to look at the vertical asymptote. So I set the denominator equal to 0, and I get a vertical asymptote at x equals 2. So we'll put that on in green. Vertical asymptote is a vertical line, and we put it on, it's dashed. And that vertical line is a line that the graph can't cross. So it splits the graph into two pieces. There's a piece on the left and a piece on the right. So we just need to keep that in mind. We're going to have two pieces to our graph. Step 5 is a horizontal asymptote. And that means we look at the degree. The degree on the top is 1, and the degree on the bottom is 1. So we use the leading coefficients. Leading coefficient on the top is 3, and on the bottom is 1. So we get a horizontal asymptote at y equals 3. So we'll graph that in, let's do orange. Horizontal line, again we put it on as dashed. And the graph is going to get close to that, but it's not going to cross it either. So it means our graph has to either be above that line or below it. So if we look at this point, these x and y intercepts here, we connect them, and the graph needs to go closer to the green line and then closer to the orange line. So that's the graph on that piece. That's the piece to the left of the vertical asymptote, the green dashed line. So now we need a piece to the right over here. So to find that, we just choose an x value that's to the right, and that's the step 6 where we choose points. So I could choose x to be 3 or 4 or 5 or 6, it doesn't matter. I'm going to just choose x to be 4. So I'm going to stick that into the original problem. So on the top it gives me 12 minus 3, which is 9. On the bottom I get 4 minus 2, which is 2. So this is the point 4, 9/2. And I can plot that. It would be right here. And what that tells me is that that part of the graph is going to be above the orange line to the right of the green line. It still has to get closer to the green line as it goes up and closer to the orange line as it goes over. And that's my graph.